Hello students, it's Ms. Cave with a lesson on solving and graphing inequalities, and this would be two-step inequalities. And we've already learned how to graph one-step inequalities with addition, subtraction, multiplication, and division, and now we're moving on to two-step inequalities. The SOL for this, if you'd write on your paper, is Virginia SOL 7.13, which is writing, solving, and graphing inequalities. So if you look here, you'll notice that this inequality is different than the ones that you've been solving so far, but very much like the equations that you've learned how to solve. The cool thing about inequalities is that we solve them in very much the same way as we solve equations. So with all of the practice that we've had from equations, we're just going to apply that knowledge to inequalities. The only difference is inequalities have multiple solutions. So when we get to the answer, we don't just have one number as an answer. Even though we get one number from the solution, we need to realize that that includes sometimes infinite number of solutions. So we're going to go ahead and start, and we're going to write our inequality over here. Negative 2x plus 5 is less than 13. I'm going to put my line down the middle, just like I do for equations. And now I'm going to begin solving. And the way I solve is just like I do equations. So I'm trying to isolate my variable. I have negative 2x plus 5. I'm going to undo my addition before I undo the multiplication. So I undo addition by subtracting. So I'm going to subtract 5 from both sides. When I subtract 5, this side cancels out. And then I'm going to bring down my negative 2x, bring down my inequality sign, and then 13 minus 5 is 8. Okay, so now I have a one-step inequality. But what do you notice about this inequality? What am I multiplying x by? A negative number. So how do I undo multiplying by a negative number? Dividing by a negative number. So I'm going to divide both sides by that negative number. What happens when I divide by a negative? What happens to the sign? It flips. So I'm going to flip my sign. So it's no longer less than, just like we learned in the last lesson. When we divide by a negative, right here, my answer, which I'm going to just write over here, is x is not less than, but greater than negative 4. Because 8 divided by negative 2 is negative 4. Okay? So what's important to remember about that particular inequality? What do we need to do when we divide by a negative? Flip the sign. Okay? So that's, if you're going to miss some of these, that's the main way that kids miss it, is because they forget to do what? Flip the sign. That's why I keep bringing it up over and over again so that you'll remember. And what the good thing is, though, when you do go to check, if you forget to flip, you'll say, oh, why are all the numbers not working? Why isn't my check working? Well, it's probably because you forgot to flip the sign. So we're going to graph it. I'm going to graph it over on the right. So again, when we graph, we're going to put the numbers in the middle. So I'm going to put the number that x is less than or greater than in the middle. So right here. And then I'm going to put the next number, negative 3, negative 5, right there. Should try to write a little smaller. Okay, and then this says x is greater than negative 4. So what kind of circle am I going to use? Open circle, because it can't be negative 4, but it's anything greater. And if you notice, some people are asking me about how you know which direction. Well, for one, on the number line, the numbers that are greater go to the right. But if you also look at the direction of this arrow, it's pointing to the right. The only problem with that is if the variable's on the other side, and then you have to reverse it. Okay, so now we're going to pick a number from the solutions on the graph to check. Marquise, what's a number that would work? What's a number that's greater than negative 4? 6. Okay, definitely 6 is. So I'm going to take my original inequality, -2, and I'm going to plug in 6 plus 5 is less than 13, and I'm going to see if it's true. So this 6 is just a number I got from my graph because I know that 6 is greater than -4. So -2 times 6 is -12 plus 5 is less than 13. -12 plus 5 is -7. -7 is less than 13, so it checks. That's what we're doing right now. So the solution in words would be, the solution set would include all numbers greater than -4. So it doesn't just say, and it doesn't include -4, right? Just greater than -4. So write not -4. Not -4 because it's greater than -4. All right, let's look at the next one. This is a little bit easier because it's a one-step inequality. So this time I have, when I have a number next to a letter, what does that mean? I'm finding the what? I'm multiplying and I'm finding the product. So this is product. So to find the product, or to find the solution to this inequality, I'm going to write it here. -5y is greater than 20. This is only a one-stepper, but how do I solve it? What am I going to do to both sides? Not add 5. I have to undo multiplication. How do I undo multiplication? Dividing. So I'm going to divide not by 5, but what? -5, because I'm undoing what was done. And then y on this side, because that cancels out, because it's 1. -5 divided by -5 is 1, so 1y. And then 20 divided by -5 is -4. And because I divided by a negative, that's really important. I divided by a negative. So what do I need to do? So I'm going to flip because I divided by a negative. So instead of greater than, it's going to be less than. So I'm going to go ahead on my number line and I'm going to put -4 a little smaller this time. -5, -3, -2, -1. I'm going to go ahead and fill this one in so I can see all the solutions on the number line. And it's less than, not less than or equal to. So I'm going to use an open circle above -4. And then because it's less than, the arrow is going to point to the left, all the numbers that are less than -4. So now I'm going to choose a number from my number line, a number that's in that solution set less than -4. So I'm going to pick -7. So I'm going to pick -5, and I'm going to multiply that by -7. And I'm using my original inequality where it was greater than before I flipped it. And -5 times -7 is 35. 35 is greater than 20, so it checks. So the solution in words would be all numbers less than -4. Okay. We're going to look at our third example. But here's what I'm going to do for this one. This time I'm going to actually rewrite that equation so that, or my inequality, so that the variable's on the other side. So let me show you. So I'm just going to rewrite it over here so that if it was on the other side, you'll know what to do. So I'm going to write 17. So if I'm going to put the variable on the other side, what should I do with my inequality sign? If you're putting it on the other side, you're going to read it like this. So 17, if negative 3x plus 2 is less than or equal to 17, that means 17 is what? Greater than or equal to negative 3y plus 2. And we're going to have to end up flipping it back, but I wanted to have an example so that you guys could see that. So I'm going to put my line down. I'm going to get rid of my negative or my positive 2 by subtracting 2. So 17 minus 2, I have 15 on the left. I have greater than or equal to still negative 3y. And now I'm looking at the side with the variable. I'm trying to figure out what I'm doing from looking at this side. How do I undo multiplying by a negative 3? You divide by a negative 3. When you divide by a negative, what happens to the sign? It does what? It flips. It flips. So what I'm going to have now, the sign is, so I'm going to get negative 5. Negative 5. Sorry about that. Trying to find some room. Negative 5, right? I'm just continuing it over here. And then because I divided by a negative, I'm going to flip the sign less than or equal to y. Okay? So that's my solution. But listen, when you have it written that way, I'm not just going to go over here and graph it. You see how the arrow, it looks like it goes to the left? Well, that's only because the variable's on the right. So before you graph an inequality like this, I'm going to go over here and I'm going to rewrite this, reading it in the opposite direction. You know how in the United States we read from left to right. Some countries they read from right to left. Yeah, different countries. So think about your reading from right to left. So we're looking at the relationship between y and all of the other numbers. So you're trying to figure out, you want to have y first so you can graph it. So I'm going to rewrite this as y is greater than or equal to negative 5. See what I did? I just rewrote this. The relationship's still the same because if negative 5 is less than or equal to y, that means y is greater than or equal to negative 5. So now, I kind of made that too close, but negative 5, negative 4, negative 6, negative 7, negative 3, negative 2, negative 8. So I've got my number line, and so now it's greater than or equal to. So if it's greater than or equal to, is that an open or closed circle? Closed, because it could be negative 5 because it's the equal sign. The equal sign right there underneath your inequality sign. So you're going to close the circle, and then it's greater than, and again, now we can go with that little trick. We can look at the direction of the arrow. So the arrow is going to be pointing in this direction. So that one I made it a little more difficult because we rewrote it backwards so that you would have an example like that. And then we had to rewrite it again before we could graph it. So a number from the solution set, negative 3. So let's pick negative 3. So I'm going to take negative 3 and I'm going to multiply that. And again, I'm looking at my graph to get that negative 3. I'm thinking, okay, what numbers are greater than negative 5? Negative 3 is. So I'm just picking any number because inequalities have multiple solutions. Negative 3 times negative 3 plus 2 is less than or equal to 17. Negative 3 times negative 3 is 9. 9 plus 2 is 11. And 11, is 11 less than or equal to 17? Yes, it is. So we check it. So for this one, solution in words, we can use the inequality sign, we can say greater than or equal to. But instead, we're going to use a different term for greater than or equal to. What's another word we can use for greater than or equal to? Okay, would maximum work? Would maximum, so if the maximum number is -5, would that work? If the maximum number was -5, that means these numbers would be included in the set. So not maximum, but what? Minimum, yes. So we can use the words a minimum of -5. Because all of the numbers that would be included in the set would be greater than -5 or -5. Could be -5, but no less than that. A minimum. All right. We're going to look at one more example. One more example. So I'm going to write this one at the top again. 4x plus 2 is less than or equal to 8. Okay, so normally again I would subtract 2 first, right? But the x and the 2 are inside what? Parentheses, so they're protected. I'm going to undo them last. So what am I going to undo first? I'm going to undo the division by 4. So I'm going to divide both sides. I'm going to undo the multiplication by 4 by dividing both sides by 4. Now watch. I'm dividing by a 4. Should I flip my sign? Don't I flip when I divide? Only by a negative. That's right. So I'm dividing by a positive 4, so nothing's going to flip this time. So I have x plus 2 is less than or equal to 2. 8 divided by 4 is 2. Then I'm going to subtract 2 from both sides, and x is less than or equal to 0, because 2 minus 2 is 0. All right, and then we're going to go to my graph, and I'm going to put 0 in the middle. 1, 2, 3, -1, -2, -3. Is this an open or closed circle? Closed, because it could be 0. And is it to the right or the left? It's going this way, right? You see that direction of the sign? It's going to go this way. And so I'm going to pick a number from the solution set. I'm not going to pick 0, because if I do my arrow the wrong way, 0 would still work, right? Because it's in the middle. So instead, I'm going to pick -1. So 4 times -1 plus 2 is less than or equal to 8. 4, I'm going to do what's in parentheses first, because now I'm evaluating an expression. I'm not solving an equation anymore, I'm checking it. So -1 plus 2 is +1. 4 times 1 is 4. Is 4 less than or equal to 8? Yes. So now, let's think about the words that we could use to describe this solution set. So we've got less than, so we're looking for all numbers that are less than or equal to 0. So how could we describe that without using less than or equal to? What other word could we use? This time we could use maximum. What else could we use? Could you use no less than? No less than? Would that work? All numbers no less than 0? It should be no more than. Yes, good. So you would write no more than 0. So no more than 0 because it's less than. So it's kind of tricky, but you got to think about those in terms of we don't want the temperature to be no more than 0, okay, if we wanted it really cold. We wanted it below 0. All right. So we have several examples now. You have 4 examples of solving inequalities, multi-step going up to 2-step. And I need you guys to go ahead and for tomorrow, I want you to have these 2 inequalities completed, and we'll go over those in class. That's it for our lesson.